Howdy, howdy, howdy. Alright, our challenge today is determine the eighth term of 24, 6, and 3 over 2. Let's have a look, see what these numbers look like in a nice little sequence. 24, 6, and 3 over 2, okay? I'm always a big fan of trying to keep your numbers in the same format, okay? So let's grab this a fraction and turn it into a decimal, or you could simply put all the other ones into fractions. I'm going to go with decimal this time just because it's only one digit after the decimal point, which is easy enough to work with. If you're like working with a number that has more than 3 digits after the decimal place, it's really probably better to keep it as a fraction. Firstly, it's a great time space saver, and it stops your math from looking messy, okay? And let's face it, the messier things are, the more likely we are to make mistakes, and we want to try and avoid that. Okay, so as we had spoken about previously, we're looking at sequences here, and we're working with two specific types of sequences, which is arithmetic and geometric. Okay, so with the arithmetic challenge, all we have to do is quickly see what we can add or subtract between the three numbers we have in front of us, and if their difference of whatever we add or subtract is exactly the same, then it's an arithmetic sequence, right? And if they're not the same, well, then we go on to geometric testing. So let's see, from 24 to 6 is we have to subtract 18. And from 6 to 1.5, we can definitely say we're not going to be subtracting 18, because that would be like -12 or something ridiculous, okay? And we know that that's not the case. So we can instantly see at this stage that we're not working with an arithmetic sequence, but a geometric. Well, we can assume a geometric. Now what we're going to do is test to see if it is, okay? Because sometimes they're going to throw stuff at you that actually doesn't fall into it, and we don't want to fall into the trap of just assuming. Assuming is not a good idea, especially in maths, okay? So let's do the trick for geometric, which is we divide term 2 by term 1. Now, let's quickly see what the values are of our terms. The value of term 1 is 24. 6 being the value for term 2, and 1.5 or 3 over 2 for the value of term 3. Okay, so let's have a look here. If we had to say term 2, which has 6, divided by term 1 is 24, and we quickly chuck it into the calculator, and that gives us a quarter. Bam, just like that. To double check it, we then move on to the next term, and we just say term 3 divided by term 2. Now, if they give you only term 7 and 8, you can still do the same, right? You can say term 8 divided by term 7, because it's got to be a constant ratio. If it isn't constant, then we don't have a pattern, right? Okay, so let's check what this is going to give us. We have 1.5 over 6. If you plug that into your calculator, you also get a quarter. Yeah, this is now proven that we have a common ratio of a quarter. Let's start building from our standard form to see what our general nth term is going to look like. Okay, so our standard form is Tn is equal to AR to the power of n minus 1. Okay, now let's go ahead and do some substitution. Well, first things first, right? What on earth is the value of A? A always represents the value of term 1. So do yourself a favor, when you're still just learning and practicing this, tell yourself what it is. There's no point in having to remember everything when you can just write it down, right? You're training yourself. It's like a muscle. So A has a value of 24, and R has a value of a quarter. Okay, and you can scribble this stuff on another piece of paper or on the same page. Keep it there. There's no point in making your life harder if you don't need to. Okay, so let's check. Tn is now going to equal 24 open bracket 1 quarter, because remember we got A times R to the power of n minus 1. Okay, that is our general nth term, at least what we assume it is. Remember, we should always test, okay? Favorite guide to check is always term 2. So let's go ahead and do that. We're going to have T 2. Notice how the 2 takes the place of n, because n is the position. If we had to read this guy, alright, it basically means the term of any position is equal to 24 multiplied by a quarter, which is to the power of whatever the position is, minus 1. Okay, that's pretty much what that formula is saying. Quite a mouthful. So let's have a look at how it's going. Okay, we now, now, what on earth was that? Okay, we now have T2 is equal to 24 multiplied by a quarter. Now we find ourselves bumping into an n. Remember, we're replacing all the n's with a value of 2. So it's going to be 2 minus 1. Okay. Simplifying this guy here, we're going to have 2 minus 1 just gives us 1, right? If we see that we have an exponent of 1, you can just leave it out, right? Because every single number we see without exponents written there, okay, is actually to the power of 1. We just don't write it, right? Otherwise we're going to have a lot of writing on one page, and it's just going to look messy again. So let's go ahead and clean that up for a second. What we're really looking at is 24 multiplied by a quarter to the power of 1, which I told you I'm just going to leave out, so let's undo it. Okay. Now, if you really want to look at it and play with this without using your calculator, obviously you can just plug it in and get an answer, but it's really good to see what's happening here. We have 24 over 1 really multiplied by a quarter. Now we can do simple stuff, cross cancelling. 24 and 4 goes into 24 6 times. Okay. Bam. We clean up that mess, which there is a fair amount of. Our answer is 6. Let's put in our little equal signs here so it looks all neat. Okay. And let's check. Is the value of our second term 6? Yes, it is. Okay. So what we've done now is just proven that this general nth term is correct. Now we can go ahead and actually finish the challenge. Okay. The challenge here is to work out what the 8th term is of the sequence. Well, that's not going to be a big problem at all, because we're just going to do exactly what we were doing, but instead of plugging in a 2, we're going to plug in an 8 to all the n positions. Okay, so we have T8. Oh, I nearly said Tn, silly banana. T8 is equal to 24 times by a quarter, and then we have another n, so that's going to be 8 minus 1. Okay, cleaning up our exponents, we have 24, open bracket, a quarter, all right, and now it's going to be to the power of 7. Okay. Let's check exactly what's cooking here. Obviously, a quarter to the power of 7 is going to be some crazy number. So at this stage, I'm actually just going to use my calculator. Why must we do something insane if we've got the tools at hand, all right? And remember, our tools make us go faster. So let's see, 24 multiplied by a quarter to the power of 7. Make sure when you plug it into the calculator that you put these brackets in, okay? Because our calculators can only do what we tell them to do, and we have to tell them how to do it correctly, otherwise our answers will come out wrong. And the answer I have is 3 over 2048. Like I told you, it was going to be a crazy number, but there we go, 3248. I hope that helped explain the process and looking at the idea of keeping our numbers in the same format. Cool. Check you on the next video.